the answer sheet in the deadline thing. So if we need to check it again, then we can.
Yeah, I will, but I'll go through them first as a group. Okay, so we can all follow. It won't take that long. Okay, so this is the homework. So this was green, but we might as well go through it all because it's quite important. This is the start of algebra. So this formula is you get the G answer by doing F plus something. So there, I look at the relationship between F and G, and I can see that, well, there's always 9 more. So if I get F, 1 plus 9 is 10. Does this work for another 1, 3 plus, so yeah, 3 plus 9 is 12. So F plus 9 always gives me the right answer here. This one, B, is A take away something. So I can just test one of the examples. 4 take away what is 1. So take away 3. I can then just test to make sure it works for another case. 7 take away 3, does it give 4? Yes. Okay. So for these examples for green, they weren't asking you to find the multiplier. So you could have found it, of course, because if I look at 5 and 6 here, they're 2 terms in a row and they'd be adding 2, so that would be a multiplication of 2. But I'll just do what they asked me to do here. 2 times k, so 2 times 3, I'm just using, once again, this one as my example case. 2 times 3 is 6, plus what gives 7, so it's plus 1, I think. I'll double check with another example, so I'm going to substitute in 12. So 12 is k, so 2 times 12 is 24, plus 1 is 25. Okay, so that works for that one as well. Next one. So, a bit trickier. 7 times x take away something gives me y. Well, let's do a test case. Let's do this one here. So, x is 5, so 7 times 5 is 35. Take away something gives me 30, so I'm thinking 5 here. Yeah, apologies for the terrible writing, but hopefully you can understand. Let's test another one to see if it works out. 7 times, well, it's 11 this time. Take away, so that's 77. Take away 5 does give 72. Okay, so that's right as well. So this is the green answers. But hopefully you're following. See, can you get these quicker than me, the rest of them, if you haven't done this yet. This one's 4 times a plus something. So let's just take a test case here. So a, 4 times 9 is 36, plus what gives 38? So plus 2. Okay. Next one. 9 times something. Okay, so let's do the second one here. 9 times m. So 9 times 2 in this case is 18. Oh, plus something gives 29. Well, that's going to have to be a large number. 18 plus what gives 29? I think it's 11. But I'll test it. I'll test this one because I'm not entirely sure. Let's do it for this one. M is 4 in this case. Will I get T out to be 47? So I'll test. I'll substitute in 4. 9 times 4 is 36, plus 11 is 47. Yes, it works. Okay, I'll do these last 4 a little bit quicker. This time we're looking for the multiplier. Now, if I look at the multiplier, I can look at all constant jumps here. So that's plus 3. There's another plus 3. 14 plus 3. 17 plus 3 gives 20. So that tells me a multiplier of 3 would be involved. Well, let's just check, just in case. Let's use this as an example to test our formula by substitution. 3 times p, so 3 times 6 is 18. Plus 2 from the formula. Does it give 20? It does. It's correct. This one, well, I can see there's a jump here between 2 and 3 when t is 5. So I think there's a multiplier of 5. So 5 times t, let's test. Let's do the last one. 5 times 12, when t is 12, is 60. Take away this 8. 60 take away 8 does give 52, so it's right. Okay. We're on to the last couple here in green. This is 3 times m, take away something. Let's do it for this one. 7 times 3, so 3 times this is 7, is m, is 21. Take away what gives 20? I want to answer 21. Next one. Whoa, that's a terrible circle. 5 times, it's a multiplier, so I'm going to look for a constant pattern. I should have done that. I can see that this jumping up in tens. 43, 53, 63. These 3 are in a row. So that's a 10, multiplier of 10, I think. Let's just double check. Let's do the last one here. 12 times 10 is 120. Take away this 7 gives 113, so that formula checks out. So do you notice the way I'm testing the formula by checking it? Here's some stuff going on in the chat. Kayleen?
May I please go to the bathroom?
Yes, Kayleen.
Thank you, Mr. Collins.
All right. So this time we have to create the formula for yellow. So I presume a lot of you did yellow. So you have to create the full formula. All right. So this one, I'm looking for a constant. This is a constant jump of 1, I think, from 4 to 5. Look for terms beside each other. That means a multiplier of 1. The rule is plus 1, so multiplier of 1. So the answer to this one is going to be B equals, so it's going to be 1 times A. So I can write 1 times A if I want, 1 times A, but hopefully we've learned to do 1A, but 1 times A, and then I'm going to have to add or subtract something. So what 1 times 5? It's just 5. Plus what gives 8? Plus 3. I'm not going to do this for all of them because I'm way too slow at writing this. So the first one would be 1 times A, or just A plus 3. Second one is going to be a similar one. Question?
I thought the first one we were finding. Wait. It's X and Y for the first one, isn't it?
No, it's A and B. Look at the screen. Look at the screen.
Sorry, I was looking at the one before your example you did in class. Sorry.
Okay. All right. So this one, I think it's once again multiplying by just 1. So the formula for this one would be W equals T, or 1T, plus 5. T plus 5, or 1T plus 5. For this one, let's look at some constant jumps here. So I think once again, it's 1, 7, 8, 0, 1. That's a constant jump of 1. So once again, the multiplier is 1. So it's going to be A is equal to 1 times M, or just M, but I need to subtract 4 to get all these answers, don't I? 12 take away 4, 11 take away 4, 7 take away 4. This is the first one with a multiplier of 2. So I can see a jump here of 2, 3, 5, 7.
What was the answer for C?
If you miss any in future, you can just, I'll be putting up the answers later, but because it's very hard for me to write here, you're going to miss a few of them. But the answer to this one again was, I have to work it out again, minus M minus 4. A is equal to M minus 4.
Okay, thanks.
Okay. All right, so this one, the answer to this is 2s. So it'll be twice because there's adding 2. 2s plus 3. 2s plus 3 for part D. Part E then. Okay, so I'm looking at a constant jump here. There's a constant jump here of 2, and then it goes, there's a double jump here, and that's 4. That's okay. So it's going to be 2 times, G is equal to 2 times F. And I think minus 1. 2 times F minus 1. Part F. So I'm looking for a constant jump. There is no constant jumps here. Oh no, they're all double jumps. 1 to 3, 7 to 9. So that's, I'm going to do halfway. Like you can put in it, if it was 2 here, I think it would be the halfway between these two is a 7. You could have that one in there. So it'd be a jump of 3. So it's 3 times in the formula. So these are tricky. And I wouldn't expect everybody to be getting these right yet. But by the end of the unit, hopefully. All right, so what's the formula? 3 times S plus 1. B is equal to 3 times S plus 1. Part G. So there's a constant jump here of plus 4. I see between 4 and 5. So the formula, 4 times D. So A is equal to 4 times D minus 3. 4 times D minus 3. And the last one here is going to be 5 times s plus 1. 5 times s plus 1. So if you're a bit like me, maybe your 5s and s's look similar. Okay, so that's yellow. I'm just going to stop sharing for a second before we get to blue. Okay, so I will put, I know that was hard for you to follow, but I just wanted to go through them a little bit so to get my thinking. I'll put the answers up again as a PDF later on. Did anyone, oh, it didn't say the answer to H, did I not? Okay, 1 second, I'll say the answer to H again. 5 times S plus 1. 5 times S plus 1. Did anyone do blue? This is what I'm correct. So if you did blue, can you
I did.
type just put up your hand actually, because I'll see that. If you did blue, just put up your hand. Wait a second. So if you did blue, as I'm looking for hands up, I see Sophia and Osborne just at the moment. Okay, I won't go through blue then with the whole group because only 2 people did it. I'll put those up on Manage Back and you guys can come back to me if you have any problems with it. I don't think they were too difficult, but you can back to me if there's any problems. Yeah, Derek, yeah. So it's formula creation. So what you should do is watch the video from last Friday or last Thursday. I did a full lesson video, it's about half an hour. So do that and catch up. If you have any questions, then come back and ask me during the next lesson. All right, so what's happening today? I'm going to switch screens now. I'm going to do substitution. Okay, so I'm on this screen now, so please maybe pin this one to your screen. Okay, so Sophia, maybe we'll look at the blue questions tomorrow during class. And maybe anybody else who wants to try the blue on the previous worksheet, if you have time at the end of today, maybe we'll go through it as a class tomorrow, because there's some interesting questions there. And you know, you should always, I expect more than 2 people in the class to push themselves and try blue. It is up to you. Okay, so well done those who tried blue. Look at the answers, see can you figure it out, and then any questions we'll get to tomorrow. All right, so today's title will be Substitution in Algebra. And I would thoroughly recommend that you take notes on this. Ramsey,
Are we writing this down on our books?
That is what I meant by thoroughly recommend you take notes, yes. Ramsey, I see you're there. Is Rustam with you? Ramsey has left the meeting. Okay. All right, hopefully they'll be back soon, but I'm going to get going with substitution in algebra. Okay, so what we just did is maybe for Derek a little bit. What we did is we were looking at patterns in order to, sorry, that's not right, in order to create formula. So we had some tables that were a number pattern. So 5, 8, 11, 4, that's the first number, the second number, the third number, the fourth number. We're looking to create formulas for these numbers. And we did that by, this is a little bit of revision of what we did on Thursday. We did that by noticing what these jumps are of +3. So the number's increasing by 3. And then we looked at that as a multiplier. We need a, if we're creating a formula, we would include then a multiplier of 3, because there's obviously, it's got something to do with multiples of 3. 3, 6, 9, but they're not quite there. So I would get it from y equals 3 times something. Well, the something is x. But that doesn't give me my answers, and we looked at that. 3 times 4 is 12, not 14. 3 times 3 is 9, not 11. So we're always a bit away. What's the formula here? Does anyone know? Can anyone type it in the chat? All right, a few of us got it. Rani, Priyanka, Osborne, Julie, Ramsey. Okay, +2. Ramsey, is Rustam with you?
Rustam's sick. I'll actually ask if he wants to do it right now. Is it like mandatory for us to join? Because my brother's really sick, so.
He's sick.
Okay. Yeah, he's like really sick, so he's being with right now.
That's okay.
Okay.
I'll be sending an email home. That's fine.
Yeah,
okay.
Sure.
All right, so this is the formula. Yeah, and a load of you got it. Well done. Okay. All right. Now, what we do to make sure it's correct is we test our formula. Because we are not sure it's correct. How do I test the formula?
You take a number from x, and then substitute that number for the variable, which is the x here. Brilliant. Or the letter.
Yep. So exactly. So this is a formula that works for all of that, and we substitute it in. Hence, substitution in algebra. So once you have a formula, you want to make sure it works. I'm going to make sure, and this is what I was doing when I was correcting the homework there. I'm going to test if I put in 4, my input into a formula. This is like a machine, and I get an output out of it. So this is like a machine, formula machine. Okay, so I should, y is equal to 3x. 3x. Now 3x means 3 times x. I'm going to show it by doing that. I put a bracket. We see brackets like that in maths. That means multiply. We see 3 bracket 4. We know this already, but I'll just double check to make sure. 3 times 4 is 12. 12 plus 2, the y value is 14. Is that what I wanted with my output? Yes. So I've inputted 4 into the formula and I've outputted 14. Input, output. This is substitution. When you replace a variable, so that's a letter, sometimes it's called a pronumeral. Pronumeral instead of number. Numeral, number, pronumeral instead of number. So a letter instead of number. If I replace a variable with a number or a value, this is substitution. I've substituted. Now, if you haven't created the formula, what is going to happen now is they've given you formulas. That means multiplying, Sophia. So if they've given you the formula and said, this formula works, now I want you to substitute in, well, that's what we're doing today. We're being given formulas. We don't have to create them anymore. And they're saying, this formula works. Can you please substitute numbers in and tell me what the output is? So that's what we're going to do today. And I'm going to give you some examples next. For these examples, I'm going to say x is 3 and y is 7 for these example questions. So you will be given variable values, what the letter is worth. Okay. So example 1, e.g. 1, 3x. What is the value of 3x? Now this should be a fairly simple operation. 3x means 3 times x. I'm going to write it 3 bracket 3. Yes, Ramsey. Instead of the x, I'm going to put a 3. 3 bracket 3 means 3 times 3, which is 9. Okay, so that's pretty simple. But remember, be very, sometimes the mistake is some people write that 3, 3, because x is worth 3. And they write the answer is 33. That's not right. 3 x's means 3 times whatever x is. Example 2. All right. So we got 3xy plus 7. I don't know why I used 3 and 7 again, but I did. I'm going to write this one underneath. So step 1, replace the variables, the letters. Yes, Ramsey, I said that's okay. Replace the letters with the variable, with the values they have. X is 3, y is 7. So 3 times x is 3, y is 7, plus another 7. Okay, so there's multiple operations going to happen here. I must do all multiplication before I do addition. This is a double multiplication. 3 times 3, and then times it by 7. Asher, I think you might have it. 3 times 3 is 9, and 9 times 7, 63, plus 7, then at the end gives 70. All right, that's 2 examples done. So all I'm doing is putting inputs into my formula and then just getting the output. And that's it. That's substitution. All right, let's look at another example. I'm going to take a similar one to your homework. What about xy over 4? Well, let's just replace first x and y, 3 and 7, in brackets like that. Okay, so x is 3, y is 7. When it's brackets and they're shoved together, remember x, y means x times y. X times y is 21. 21 divided by 4. I would simplify the top first and then do division, multiplication, division. So this comes first. Yes, Asher, that was wrong. We did 3 divided by 4 first. So I have 21 over 4, and that's fine for me. So I just did this, and it's an improper fraction. Let's just convert it to a mixed fraction. So 4 fits into 25 times, and we're left with a remainder of 1. So there's 1/4 left. Okay, so that was a bit of fractions to finish. But the thing we must remember is replacing x and y, those variables, with letters. Yeah, you try and avoid decimals, because mathematicians tend to avoid decimals because they're slightly inaccurate. Fractions are more accurate than decimals. Okay, I'm going to do one more example, one final example. I'm going to write it here, and let's see who can get it right first in the chat. So, 2x squared minus y squared plus 7 over x. And I want your answer as, this is a tricky example. I want your answer given as a fraction, not a decimal, please. Yeah, so this is testing your formulas, but this time they told you, Sophia, that this formula works. So you don't have to test anymore, you're just getting the output and just doing it for one value or one time instead of doing it multiple times. Yeah. So let's see, can anyone get this? This is a tricky formula, but can you get the output when the inputs are 3 and 7? And I want your answer as a fraction, please, not as a decimal. And type it in the chat. Asher thinks it's 2.
Mr. Collins,
Mm-hmm.
somehow I got 2 with other decimals.
No,
but I just
we're
found
gonna,
it.
Caleb, people are still working on it. Don't give away your secrets. I'll go through the answers. A lot of people are thinking 2. A lot of people are thinking 2. You're just agreeing with what Asher and Caleb and Lewis said just because that's it. I don't think it's 2. For instance, I'm looking at y squared here and knowing y squared is y times y. And I know y is 7. Okay, Lauren. So Julia won't take minus 28.7 because that is a decimal. So I need it to be a fraction. All right, if you're working on it, keep working on it. I'm going to go through really slowly on this next page. So Asher's changed his answer to minus 2. Here it is, 2x squared. Don't want it as a decimal and disregarding decimal answers. That's using the calculator. I want to use a non-decimal. I want it as a fraction, and I don't want it as a mixed fraction. Oh, sorry, I don't want it as an improper. I want it as mixed. All right. I remember from before, x is 3 and y is 7. So that is 2 times, well, x squared, well, that's going to be 3 squared, minus 7 squared, plus 7 over, well, what's x? X is 3. All right, so I've replaced x twice with 3, and I replaced y with the 7. All right, so I don't need that page anymore. Now, I could rewrite this line as 3 times 3 if I wanted, minus 7 times 7, because of course that's what 7 squared and 3 squared is. Okay, there's a few people on the 280 and 7/10 train. Interesting. This is 7/3. It's 7/10. Same as before, Sophia. X is we haven't changed. X is for all these questions. X was 3, and Y is 7. Now, when you're given questions for homework, they're going to be different. X is 3. Okay, so I've replaced X with 3 and Y with 7. And remember, 3 squared is 3 times 3, and 7 squared is 7 times 7. Well, there's a few people on the 280 and 7/10. Asher's changed his answer to 8 and 2/3. All right. Well, let's work out this first. 2 times 3, 6. Times 3, 18. Okay. Minus. Well, 7 times 7 is 49. Plus 7 over 3. All right, I'm going to do this bit first because do it from left to right, order of operations when it's adding and subtracting. 18 take away 49, and that goes into the negatives. I think I'm on negative. 18 take away. Oh, negative 31, is it? I think it's negative 31 plus 7 over 3. All right, so this is going to test my knowledge of fractions. Well, I need a common denominator between 31 over 1, I suppose, and 7 over 3. The common denominator would be 3. So if I multiply this by 3 over 3, so this is just fractions now to finish, multiplying the top by 3 and the bottom by 3 to get it over 3. We're all changing our answers here. I don't want it as a decimal, Sophia. It must be a fraction. Minus 93 plus 7 over 3. Now, I know my answer is going to be out of 3, but minus 93 plus 7 is going to be, well, minus 93, if we think about it on our number line, is like back here somewhere, minus 93. If I add 7 to it, I got to go this way, 1, 2. So the next one up will be minus 92, minus 90. I'm getting closer to 0. And the same with 97 thirds, if you think about it. So it's going to be 86, yeah. If I keep doing that, it's going to be 86, negative 86 thirds. Now, I didn't want my answer as
an improper fraction. So I got to get a proper fraction. So many times does 3 fit into 86? Let's do a little division here. 3 into 86. 3 into 8 goes twice. Carry the 2. 3 into 26 goes not quite nice. 28 times. So I think, Ethan, you're onto a winner here. My remainder of that would be 2. Okay, let's go back up. Put that the answer. 28 whole, remainder 2. It was thirds, and it was negative. So negative 28 and 2/3. First person to get that, I think, was Ethan. Nice work, Ethan. Don't know, did anyone get it before you? No, I don't think so. Yeah, okay. So that was there's no question in the homework that's as difficult as that, but it can be, you can see how it is applied. Any questions, any of that? We're going to do something else before we do the homework, but any questions on just this? No? Okay, so remember, these formulas are machines. You input numbers into them and you get numbers out. Rani, question?
When is this homework going to be due?
Wednesday.
Okay, thank you.
Okay. All right, so